Welcome everybody, welcome to a live stream. Today we're going to be running through the 7th lesson of the Networking Fundamentals series. I am excited to present this to you live. This will give me an opportunity to kind of run through the material with you all for the first time. And if there's any questions or feedback or anything you guys want to provide, I'm definitely open to that at the end of the lesson. In the meantime, let me quickly check in with the chat. Can you guys see me okay? Is everything coming through? Mention something in the chat room if so, and otherwise we will get right into it. Now, depending on when you guys are joining, there is a poll that I asked asking for your favorite lesson of the Networking Fundamentals series. Please go ahead and throw an answer in that. It'd be fun to see what you guys see. Cool, glad you guys can hear me. The polling system only lets me pick 4 options, so I had to pick 4 of the 5 lessons that have already existed. So sorry, lesson 1 fans, you can't vote for that one, unfortunately. In any case, welcome. Super excited for you guys to be here. Yeah, I hope you guys have gotten a lot out of the Networking Fundamentals series so far. Today we're going through essentially the final lesson. This is the lesson that ties everything together. Way back we learned in lesson 1, lesson 2, lesson 3, we tie it all back together into one large illustration of packets moving through a network. So with that said, let me turn on my screen share and we'll get right to it. Okay. So if you don't already know, the plan for this is to one day turn this into a complete networking course where we unpack everything we've talked about in this module, but with more detail. The 5 lessons we've released so far. Oh, and the protocols lesson. I totally forgot about that lesson. That was the one that was released last week. In any case, all those lessons so far are all module 1 of what would be the full course. So the idea is module 1 is what I'm giving away for free, giving away to everybody. It's always going to be available on YouTube. And if people are interested enough in the full course, hopefully they can show me that by engaging with the videos, sharing the videos. And if we reach a certain viewership, then I will commit the time and resources to creating a full networking course in the same style. So today we wrap up the first module with our final lesson, the packet traveling lesson. Cool. So everything we've talked about so far in the Networking Fundamentals series sort of culminates, oops, let me move my head to the other side. Cool, sort of culminates with what's going to happen today. Today, we're going to run through everything you need to understand how data moves through a network. So far we've picked apart things in their individual instances. We've talked about the OSI model. We've talked about the purposes of each of those layers. We talked about everything hosts do when they're communicating to each other, regardless of how they are actually communicated, whether they're connected with one switch or no switches or multiple switches. We also talked about how the switches actually work, whether they're doing learning and forwarding and flooding and the 3 actions of a switch. Then we also talked about how hosts speak to each other on either side of a router. And we also showed you that whether they're connected via one router or multiple routers, which essentially simulates how hosts speak on either side of the actual internet. So all this is stuff we've covered prior in this course. Today, we're going to go through the summary lesson. We're going to tie all of that stuff together. Now, the key of understanding how data flows through a network really comes down to understanding 3 different tables. Those 3 tables are the MAC address table, the ARP table, or also sometimes referred to as the ARP cache, and then the routing table. Now, each of these we picked apart in great detail in the earlier lessons in this series. But to give you a quick summary, each of these tables is essentially a mapping of one thing to something else. A MAC address table is a mapping of a switch port to a MAC address. A ARP table is a mapping of an IP address to a MAC address. And finally, a routing table is a mapping of either IP networks to interfaces or IP networks to the next router in the path, also sometimes referred to as the next hop. Understanding how these 3 tables work is really the foundation to understanding how data moves through a network. To that end, I'm going to show you these three tables in this topology. I'm going to show you how each of these devices use one or more of these tables to move data along. Now these devices exist in three different networks. So we've got host A, host B, host C in the 1188/24 network, the 2277/24 network, and the 3366/24 network. Each of those networks are maintained by a particular router. So we've got three routers, router 1, 2, and 3. And then everything here has a MAC address and an IP address as well. And again, I'm only showing you the first 4 digits of the MAC address just to keep things a little bit shorter. Our switch doesn't have an IP address or a MAC address because we are not sending traffic to the switch. We are only sending traffic through the switch. So the switch's IP and MAC is irrelevant in this illustration. And again, we unpack that in the switch lesson back in lesson 4. Now I'm going to show you everything that happens insofar as these tables. So we have to show you a copy of each of these tables. So let's talk through it. Our switch is only going to have one of these tables. It's only going to have a MAC address table. So that one will be somewhat simple. Then our routers, each of our routers are going to have 2 of those tables. They're each going to have an ARP table and a routing table. And you're going to see this right here is router 1's ARP table and routing table. And then this right here is router 2, and this right here is router 3's ARP table and routing table. And finally, our hosts, as layer 3 devices, also are going to have ARP tables and routing tables. So I'm going to show you how each of these tables will be populated and used for each of these devices as we move data from host A to host B and back, and then from host A to host C and back. Cool, so Jay in the chat just mentioned that the pixel quality is lower. Can some of you see this in HD, or are all of you seeing this only in 144p? Go and answer that in the chat. Let me know if I'm having any sort of tech issues that I need to look into. Oh, hey Jeremy, welcome. Glad you could join us. Cool, awesome, thank you. So Jay, it might be something on your end. Maybe refresh the browser or something along those lines. Awesome. Glad it's working for the rest of us. Cool. So this is essentially the topology we're going to be working on, and I'm going to show you. And I'm going to show. There it is. Cool. And I'm going to show you everything that happens to move data through this network. Now, each of these tables are typically populated dynamically. Awesome, Jeremy. Glad you could join us. Yeah, so each of these tables are typically populated dynamically, which means as traffic is flowing through the network, these tables will be populated and used by these very devices. There is one exception to that, and that exception is the routing table. Recall back in lesson 5, I told you that if a router receives a packet that it doesn't know how to deliver, that it doesn't have an entry for in its routing table, it's just going to drop that packet. So if we start right now with all the routing tables empty, all the data going through this network, we're just going to be dropped. So before data ever shows up on this network, we have to populate all of the routing tables so that data can properly be flowed and route through this particular topology. So let's start there. So starting with host A only has really one entry in its routing table. It's actually also going to have a directly connected route, but we'll leave the details of that aside. Host A's route table entry is really host A's default gateway. Now again, we talked about default gateways a few different times in this module, so feel free to refer to prior lessons for more details. But essentially, this route is telling host A that to get to anything outside of host A's network, use router 1's IP address, which is 11.8.8.1. That's this IP address right here. The other hosts in our topology are going to have something similar. Host B's default route will be pointing to router 2's IP address right there, and then host C's default route will be pointing to router 3's IP address right there. Which now brings us to the actual routers. Now each of these routers has 2 entries in their routing table. The easiest entry is what I'm going to call, is what's called the directly connected entry. You'll notice that router 1 has a route table entry for the 11.8.8 network because it is directly connected to that network. Router 2 has a directly connected route for the 2277 network, and then router 3 has a directly connected route for the 3366 network. Moreover, each of these routers is also going to have a default route pointing the router to deliver traffic not to their directly connected routes out towards the internet. So from router 1's perspective, anything that matches this route will be delivered out its left interface out to the 1188 network, and then anything else will go out towards the internet. And then we have the same thing on the other routers as well. So that's going to be the starting point of this particular topology. And understand this needs to be set up before any traffic has showed up on this particular network. With that said, we can now actually start by showing you data being sent from host A. Now, I want to show you what's going on with this data in more detail, but there isn't really enough room to add things like source IP address, source MAC address to that packet here. So instead, I'm going to show you a copy of that packet as it's moving through the internet in this box right here. To start, host A is going to throw a layer 3 header on that packet, on that data, because host A is going to try and deliver, or rather wants to deliver, the data, the ones and zeros, from host A to host B. Notice the source IP address is host A's IP address. That's 11.8.8.11. And the destination IP address is 22.7.7.22. That's host B. So this is essentially our starting point, and we are now going to show you everything that happens and all the tables that are involved in moving data through this network. Let's move this guy over here. Okay, here we go. So the first thing host A is going to do is it's going to take a look at the destination IP address and determine that the destination IP address is on a foreign network. This tells host A that this particular construct, this packet, needs to be delivered to the nearest router. So host A is going to look at its routing table, take a look at its default route to determine the nearest router's IP address. The IP address is 11.8.8.1. Now, at this point, host A wants to put together a layer 2 header that looks something like this. But the problem is host A doesn't know the MAC address for the IP address 11.8.8.1. If we look down there, we can see that host A's ARP cache or ARP table is empty. Therefore, host A is unable to put together the layer 2 header at this point. What host A needs to do is run through ARP, or the address resolution process. So it's going to put this particular packet on hold. It's just going to reserve it, hold it to the side for a minute, and then it's going to send out an ARP request. The ARP request is a question to the entire network, asking the network if anybody knows the MAC address for the IP address 11.8.8.1. Remember, this is where this packet needs to go because it's trying to deliver it to router 1. This is what the ARP request would look like. The layer 2 information would have a source of host A's MAC address, since host A is sending it, and then the destination is all F's. And again, we covered that in detail in lesson 3. The all F's MAC address is a broadcast MAC address, meaning it is a packet meant to be delivered to everybody on the network. To answer your question, I'm using PowerPoint. In any case, this ARP request will be sent out onto the wire, where the first place it'll arrive is on the switch. So now we focus on the switch for a moment. The way switches work is anytime they receive traffic, they're going to do the learning action. The learning action has the switch record the source MAC address and the receiving inbound switch port. I should say, create a mapping between the receiving inbound switch port and the source MAC address. So once that ARP request gets there, the switch is going to be able to learn this entry. It's going to say, I just received something on port 4 that had a source MAC address of A1A1. That's the learning function of a switch. And again, we unpacked that in more detail back in lesson 4. Now, the switch needs to figure out what it's going to do with this packet. It's going to look at the destination MAC address, which is all F's, and that instantly tells the switch that this packet should be delivered out all switch ports, except the one it came in on. Now, in this particular instance, there is only one other switch port, that's out port 5. But if we had a bunch of other things connected to this switch, they would all be getting a copy of that particular frame. In this particular instance, however, since there's only one other switch port, this particular frame or ARP request will be sent out switch port 5, where it'll finally arrive on router 1. Now that it's arrived on router 1 will accept the ARP request, but right before it in the processing of the ARP request, it's going to learn something about the sender of that ARP request. Recall back in the hosts lesson, we talked about how ARP works, and included inside the ARP payload is not only the question that we're asking, but also the MAC address to IP address mapping of the sender, which means inside here is the IP address and MAC address of host A. So router 1, upon receiving that, will learn the ARP mapping for host A. It's going to record in router 1's ARP table that the IP address 11.8.8.11 maps to the MAC address A1A1. Yeah, so R1 receives the packet, and then R1 is going to generate an ARP response. The ARP response looks like this. Note that the ARP response has a source MAC address of R1 and a destination MAC address of host A, A1A1. This is a unicast frame, as opposed to the ARP request, which was a broadcast. This frame is unicast, meaning it's meant to be delivered directly back to host A. So router 1 will put that onto the wire, where it'll arrive on the switch on port 5. This will allow the switch to do its learning action again. The switch will learn that it just received something on port 5 that had a source MAC address of EEE1. Now the switch will look at the Now the switch will look at the destination MAC address. In this case, the destination MAC address is A1A1. The switch will consult its MAC address table, and it'll determine that the MAC address A1A1 exists out port 4, and then this frame will be sent out port 4 will be forwarded out port 4. Where finally host A will receive the request that it was looking for. Upon receiving the ARP response, host A will populate its ARP table with the mapping included in the ARP response. That mapping is the IP address of router 1 and the MAC address of router 1. And now that host A has the ARP response, host A can finally put together the layer 2 header necessary to deliver this packet to router 1. Since this is going to a foreign network, the route tells host A that this should be delivered to 11.8.8.1. And since host A knows the MAC address for that IP address, host A can put together a layer 2 header that'll take this packet from host A's NIC, that's a source of A1A1, to router 1's NIC, that's a destination of EEE1. So that will get sent onto the wire, where it'll arrive on the switch. The switch will then go through its learning action, but in this particular case, the switch has already learned that the MAC address that exists out port 4 has, the switch will already have learned that the source MAC address A1A1 exists out port 4. So there's nothing new for the switch to learn. Instead, this entry in the MAC address table will simply be refreshed. MAC address tables typically have a timeout. It's different for every vendor, but what I've seen pretty commonly is a timeout of 5 minutes. Meaning if nothing happens on port 4 from this MAC address, the switch will purge that entry. But in this case, since a new packet just showed up, this entry gets refreshed in the switch's MAC address table. So there's nothing new for the switch to learn. Then the switch is going to look at the destination MAC address, EEE1. It's going to determine that the MAC address EEE1 exists out port 5, and this particular packet will be sent out the switch out port 5, where it'll arrive on the router. Once it gets to the router is going to discard the layer 2 header. Remember, this layer 2 header sole purpose was to get this packet right here from host A to router 1. So since that header did that successfully, we no longer need it and we can get rid of it. And at this point, the router will take a look at its routing table and compare the destination IP address to the entries in nose to figure out where it's going to send this packet next. Now in this particular case, this destination IP address only matches the default route, so router 1 knows that it's going to go out towards the internet. Now in reality, the internet is really just a bunch of other networks. Sorry, a bunch of other routers. And technically router 1's default route is not just going to kind of vaguely point to the internet. It's going to point to a specific router out on the internet. But we showed you essentially earlier in this course, back in lesson 5, how routers hand data to each other. So rather than just repeat that to you, I'm going to point you to those videos if you want to see how that happens. As for us, we're just going to abstract that out and say this packet was just going to be handed from router to router as it bounced across the internet, where it'll finally arrive on router 2. But the actual details of how all that works was covered in, I believe it's the last part of, part 2 of our lesson on routers. So definitely check that out if you want to see more details about what happened from router to router to move this packet along. Cool. So now router 2 has our packet. And again, this is what our packet looks like. Once router 2 gets this packet, it's going to look at its routing table, which is up here. And it's going to compare the destination IP address to the entries it knows. And it's going to determine that this particular packet needs to be delivered out the directly connected network. That's out this direction. Then it's going to look at its destination IP address of the packet to see if it knows the ARP entry for that particular destination. In this case, it doesn't, so it cannot put together the layer 2 header to get the packet to host B at this point. This is what it wants to do, but again, because ARP is empty at the moment for router 2, it doesn't have the necessary information, specifically that MAC address right there, to create this layer 2 header to get this packet across the next hop. So, just like host A did a moment ago, router 2 is going to have to put this packet on hold for a minute and then go through the ARP process. So it's going to put this packet on hold, and this right here is our ARP payload. The ARP payload, just like before, is a broadcast. It's being sent from the MAC address of R2 to the destination MAC address of all Fs, which is the broadcast MAC address. Now, you'll notice here there is no switch. The thing is, if there was one switch here, or 2 different switches here, or 3 different switches, really we'd be doing the exact same thing we did back here over and over again, and that would get a bit repetitive. I showed you how traffic flows through switches and through multiple switches back in lesson 4 was the switch lesson, so check that out if you want more details. For now, to keep this simple, we'll kind of speed this along. Router 2 is going to shoot out the ARP packet, which is going to arrive on host B. Once host B gets it, host B is going to learn the ARP mapping of the sender. Now I know it's kind of hidden in the live stream because of my face, but let's see if we can move this real quick. Yeah, this will work. Cool. So host B learns the ARP mapping of the sender. That is router 2's IP address, 22.777.1, mapped to the MAC address EEE2. Host B will learn this upon receiving the ARP request from router 2. Then host B will process the ARP response, will send an ARP response. That ARP response is going to look like this. It has a source MAC address of host B's MAC address and a destination MAC address of router 2's MAC address. That will get sent out onto the wire, where it'll arrive on router 2, and then now router 2 can populate its ARP cache with the mapping for host B. This now allows router 2 to complete the layer 2 header it needed to get that packet to host B. Now, router 2, since it has host B's MAC address, can create a layer 2 header with the correct destination MAC address, which will take this packet from router 2 and deliver it to host B. Once it's arrived on host B will discard the layer. Host B will discard the layer 2 header Again, the purpose of that header was just to take this packet from here to here. Then host B will discard the layer 3 header. The purpose of that header was to take this data from host A to host B. Since it did that successfully, we no longer need it. And at this point, host B can process this data. So that is every step that's needed to get something from host A all the way to host B. But what about the response? Well, now we're going to step through the response of traffic from host B, rather of host B trying to send some data all the way back to host A. It's going to start with host B throwing a layer 3 header. Oh, and I should say that response will go much quicker since all of the MAC address tables and ARP entries for this particular flow have already been populated. You'll see that all of this will go much, much quicker. So again, host B will throw a layer 3 header onto that packet. That layer 3 header includes the source address of host B, which is 22.7.7.22, and a destination IP address of host A, which is 11.8.8.11. Oops. Host B will determine that that destination is on a foreign network, so that packet needs to be delivered to the IP address 22.7.7.1. That's router 2's IP address. And since host B has the MAC address, has the ARP entry for this IP address, 22.7.7.1, host B has everything it needs to create the layer 2 header that'll take this packet from host B's NIC to router 2's NIC. Notice the source and destination layer 2 header included host B and router 2. The important thing is to understand that host B used its routing table to figure out the next IP address it should send the packet to, and then its ARP table to actually figure out the layer 2 header to add to that packet. That's what will get the packet to router 2. Just like before, when router 2 gets it, router 2 is going to discard the layer 2 header. Again, the purpose of that header was just to get the packet to router 2. And upon receiving that packet, router 2 is going to look at its routing table to determine where to send that packet next. In this case, the destination IP address only matches this route, and so this packet should be sent out to the internet, which again, we've abstracted out, but sooner or later, the packet is going to arrive on router 1. When router 1 gets it, router 1 is going to look at router 1's routing table, and it's going to determine that, that particular packet matches the directly connected route. Notice the destination IP address is in this network. Then router 1 is going to consult its ARP table to see if it knows how to get a packet to the IP address 11.8.8.11. In this case, it does, which means router 1 has everything it needs in order to put together a layer 2 header to get a packet to the destination MAC address A1A1, which is host A's MAC address. Now, this will be sent on the wire out by router 1, where it'll arrive on the switch. And again, the switch will take a look at the layer 2 header and the source of the layer 2 header to create a mapping between the source MAC address and the received switch port. In this case, the switch already knows that the device out port 5 owns the MAC address EEE1, so that entry will be refreshed in the MAC address table. And then the switch is going to look at the destination we'll look at the destination MAC address to determine where to forward that packet next. The destination MAC address A1A1 exists out port 4, so the switch will forward this packet out port 4, where it'll arrive on host A. Once it gets there, host A will strip the layer 2 header. Again, the purpose of that layer 2 header was just to create, to jump that hop, if you will. Then host A will strip the layer 3 header. The purpose of that header was to handle the end-to-end delivery of that data. And finally, host A will process the data. So that's what it took to get the packet back from host B to host A. Now you'll notice it went much quicker since the MAC address tables and the ARP tables were all already populated. The last step for this topology is then going to show you host A speaking to host C. Now, once again, this is going to go quicker than it's gone before because a lot of the ARP entries and MAC address tables have already been populated, so we don't have to go through those steps. But to some degree, it is going to be somewhat repetitious of what we've already done. You see, networking devices all follow a set of rules, and we outline the specifics of those set of rules in lessons 1 through 5 of this particular series. And all networking devices are simply just going to, on repeat, go through those same rules every time they encounter a packet. They're going to check the source MAC address, check the destination IP address, check all the stuff that we've already discussed in this particular illustration. So for this part, host A speaking to host C, I'm hoping you can essentially follow along and guess ahead of time what's going to happen, since you've already seen the process a few times, and definitely many times if you've seen the rest of the lessons in this particular series. With that said, let's get into it. So now host A is going to put together some more data. Let me again move my face. Move it back up here. Sweet. So now host A is going to try and send this data to host C. Just like before, it's going to throw a layer 3 header onto that data. That layer 3 header is going to include the source IP address of host A and then the destination IP address of host C. Then host A will take a look at its routing table to determine that this destination IP address, rather that packet, needs to be delivered to router 1's IP address. And since host A already has the ARP entry for router 1, it can use that same ARP entry to create the layer 2 header that'll take this packet to router 1. So host A will put that onto the wire where it'll arrive on the switch. The switch has nothing new to learn, so it'll simply refresh this particular entry in its MAC address table, knowing that something on port 4 was just received with a source MAC address of A1A1. And this frame is meant to be delivered to EEE1, which exists at port 5. So the switch will send it out port 5, where it'll arrive on router 1. Once it gets to router 1 will strip the layer 2 header. Then router 1 will take a look at the destination IP address to determine where to send this next. And this particular destination needs to be sent out to the internet. So that'll get punted out to the internet, where it'll arrive on router 3. Router 3 will take a look at router 3's routing table to determine where the destination 33.6.6.33 exists. Router 3 will know that it matches this particular route, which means this packet needs to be delivered to the final hop. But router 3 at this point doesn't have the ARP entry for host C, so it does not know the MAC address to use to create the layer 2 header necessary to get this packet to host C. So router 3 will put this packet on hold and run through the ARP process, just like we've done many times before. That ARP process is going to be asking for the MAC address of host C. It's going to be sent as a broadcast, meaning sent to everybody on the network, so we know host C is going to get it. Host C gets it, and then upon receiving the ARP request, host C is going to learn the ARP mapping of the sender. Again, that's included inside the ARP payload. Then host C is going to process the ARP response. The ARP response is going to be sent unicast from host C's MAC address destined to router 3's MAC address. It'll get sent onto the wire. Router 3 will get it, and then router 3 will populate its ARP entry or ARP cache with the new MAC address mapping. Now, router 3 can finally put together the correct layer 2 header to get this particular packet to host C. This will finally get the packet to host C. Host C will strip the layer 2 header, host C will strip the layer 3 header, and host C will process the data. Then host C will generate the response data. That response data needs to be delivered from host C to host A. So host C will throw a layer 3 header that includes the ends of this particular conversation. In this case, host C's IP address and a destination of host A's IP address. And then host C knows that this needs to be delivered to router 3, the IP address 33.6.6.1. And host C has the ARP entry for that particular IP address, so host C has everything it needs to create the layer 2 header necessary to get this data across this hop. That'll get sent onto the wire, where it'll arrive on router 3. Router 3 will strip the layer 2 header. Again, it only existed to do this particular jump. We no longer need it. It did its job successfully. Then router 3 will consult its routing table to determine that this packet should be sent out to the internet, where it'll bounce around from router to router and finally arrive on router 1. Router 1 will take a look at its routing table to determine that this particular destination IP address is directly connected to router 1. And so then router 1 will look at its ARP cache to determine that the layer 2 destination for the IP address 11.8.8.11 should be A1A1. And since it already has that information, it can simply create the layer 2 header and pass that packet along. It'll arrive on the switch. Again, the switch will refresh its MAC address table for port 5, and the switch will consult the MAC address table to determine that this frame should be set out port 4, where it'll get put back onto the wire. And finally, host A will strip the layer 2 header, strip the layer 3 header, and process the data. And that is what would happen in order to get something from host A to host C and back. Now you'll notice it did go much quicker because again, most of the tables have already been populated. In real networks, this happens in the first 1 to 2 seconds of a network being turned on or whatever the case. And then right away, all they do is simply use the MAC address table, the ARP table, and the routing table to simply move data along. So if you followed this lesson, and you followed all the other lessons in this particular series, then you should be well on your way to understanding how data flows through the internet. The last idea I want to leave you with has to do with something I mentioned in the description and the title of this particular live stream. I said this live stream will teach you how to answer a top interview question for network engineering type positions. That top interview question looks something like this. When you type www.google.com into your web browser and hit enter, tell me everything that happens. Well, essentially there's two parts to it. Remember that host-to-host communication needs to be from an IP address to another IP address. If all you do is type www.google.com, you're not providing an IP address. You're providing a domain name. So the first thing your computer has to do is send a DNS request to a DNS server in order to translate the domain name into an IP address. Well, we just talked about everything that would happen for a packet to go from host A all the way to host B. But what if host B isn't actually just some host on the internet? What if host B is actually the IP address of the DNS server? Well, we showed you everything that would happen to get that DNS request from host A to the DNS server. The next thing that would happen is after you receive the IP address from the DNS server, you would then make an HTTP request to the web server for google.com. Well, what if host C isn't just host C? What if host C is the actual web server for google.com? If we consider host B and host C as the DNS server and the web server, what we just did, our illustration of talking through the different tables and the ARP tables and MAC address tables and how packets flow and checking all the routing tables and all that fun stuff, is essentially the perfect answer to this question. Now, I've interviewed easily, I could say hundreds, maybe not thousands might be too much, but easily hundreds of network engineers. And in some way or another, this question almost always comes up. It's a great question to make sure the person you're interviewing really understands what's happening underneath the hood, how networking is happening. The neat thing is this is completely vendor neutral and vendor agnostic. This is how Cisco networks work. This is how HP networks, Juniper networks, Arista networks. Every vendor is essentially following the rules of switching and the rules of routing, which we outline in detail throughout this series. And that is actually the last thing that I wanted to leave you with in this particular lesson. So that wraps up our lesson on networking fundamentals, or at least module one of the full course on networking fundamentals. The last illustration of it was us taking packets from host A, and walking it through this particular network to see everything that happens for data to flow through this topology. With that said, I hope that was useful for you. I hope you enjoyed that. I'm going to now turn it over to the chat room. How did you guys think that went? Do you have any additional questions? Any feedback, any thoughts, any concerns, positive, negative? Go ahead and throw it out there. Love to hear from you. Cool. I just saw Jay's question, and Azza answered it correctly. Correct. The switch will learn whenever things arrive. And there's more detail on that in lesson 3 of this particular module. Awesome. Cool. Super glad you guys are enjoying this. A lot of this, and I mentioned this, I think, in other places, a lot of this content is me thinking back to when I was initially learning networking and me saying, man, how do I wish someone had explained this to me when I was trying to understand all this? And hopefully this is a way of helping you all on your networking journeys. Frank, I would say the beginning. So I'll show you guys. If you go to pracnet.net/NF, NF standing for Networking Fundamentals, it'll take you to the full blog article over here where I posted this entire series. Oops, I'm still highlighting. So my blog is Practical Networking. You can get it at practicalnetworking.net. But in any case, this particular post is the post that has all these videos that you can access from one place. So if you come down in here, you can access all the lessons in this particular video. Pretty much all the lessons are 2 parts. So this is part 1 and 2 of lesson 1, part 1 and 2 of lesson 2, etc., etc. Lesson 5, I decided to make into 3 parts. So you've got that. Lesson 6 released this last Monday. Yeah, today's Thursday. So released like 4 days ago. So definitely check that out. And then finally, this live stream is essentially lesson 7. Now, what I'm going to do is re-record this live stream and make it all pretty and edit it and all that fun stuff so that it's a bit more succinct and not quite as dynamic as this particular was. So soon you'll see that this will get updated with the link to the final polished version of this particular video that we ran through today. Cool. Okay, so let me ask a few questions. Or answer a few questions. Cool. Awesome, that man. I'm glad you can now picture it in your mind. That's perfect. Frank, I just answered your question. Sweet. So Ruben asked, what happens when a switch receives an ARP request and destination MAC address is not on the ARP table? For that answer, Ruben, I would suggest take a look at these 2 lessons. Actually, I think the first part will actually answer your question, lesson 4A. So I'll show you exactly what a switch is doing and what a switch does and when and all that fun stuff. So definitely check that out. Awesome, Jahid. Thank you. Glad you enjoyed it. Yeah, we'll talk if we go through. So again, like I mentioned earlier, the plan is for this to one day become a full course. And I've kind of briefly scoped out what the outline would look like in the full course. This is all, it's very dynamic. So I'm still kind of playing around with what I'm going to add to the full course or not. But again, at the end of the day, it's all going to come down to how big of a reach Module 1 receives. So Module 1 I've given away for free. It's on YouTube. And depending how many people that reaches or how big of a, how many people that reaches, that's what's going to determine whether I decide to actually commit to doing the full course or not. So if you really want to see the full course, the best bet would be to help me spread the word about this video. Tell your friends, tell your colleagues, post it online, post it at different networking forums. I like to think, a few people have already said, but I hope that the content is really well put together and really good at teaching how networking works. And almost any tech role needs to understand networking, especially now with everything being connected and the cloud and all that fun stuff. So definitely check that out. Awesome, Robel. I appreciate it. This is actually the first time I've received a donation in chat, so thank you so much. It's very kind of you. Thank you for your support. Cool. So that answers Shahid. Ann's asked what happens if the interview asks how packet flows from the DNS server back to the web server. Well, luckily, the DNS server never actually needs to speak to the web server. The DNS server essentially is standing on its own, and its sole purpose is simply to translate an IP address, a domain name to an IP address. So the DNS server will never actually speak to the web server. Cool, awesome, correct. The description has more videos. Awesome, this will help. Frank asked, will this help cybersecurity? Absolutely. Again, as I just mentioned, I think any tech disciplines, whether you're a software engineer or you're a systems admin or into cybersecurity or pen testing, it's fundamental to understand how networking works. And the neat thing is all you really need is this first module, right? You probably don't need the rest of the course if you're in cybersecurity, but you do need this first module, right? Which I've given away for free. So yes, I think this will definitely help you. Awesome. So Kranti asked about actually some cryptography content. So that's actually very, very interesting that you mentioned that. So I actually, let's see, let's just go to it. So I actually have an SSL and TLS course that I released, I think like last month or so. So it's brand new. It's actually really, really high quality and really, really thorough. So if you're trying to really understand SSL and TLS, like to a very deep degree, that means RSA, Diffie-Hellman, elliptic curve, forward secrecy, all the hashing algorithms, how it all works, this is definitely the course for you. Now, in about a month or so, I'm going to start releasing some of those lessons for free onto YouTube as well. In fact, I'm planning to release the cryptography module. So that's going to cover a lot of the things that you mentioned, Krunti. If you're interested in the practical TLS content, you can go to pracnet.net/TLS. I'll do it right here, pracnet.net/TLS. Yeah. That's how you can get to the details of the TLS course. If you go to my website, which is practicalnetworking.net, I think I released, there it is. I released the first module of that for free. And here's the the content of that. So I've released the first few videos of that all for free. You can check that out now. But I'll be releasing the cryptography stuff probably next month or so. But of course, if you're interested in the full course, I'll definitely check that out. In fact, I believe this code, oops. That coupon code will give you $100 off the full course if you're interested. So that was for Krunti. Ramzan, also for you if you're interested in security, that will be very useful for you as well. Cool. vManage. I'm not 100% sure what vManage is. If Jeremy is still in the chat, he's doing a full Cisco CCNA course. Definitely check that out if you get a chance, but he might be able to chime in for that. Awesome, Jay. Yeah, I started my networking career also in the upper layers and kind of moved my way backwards. Awesome. Well, I think that spoke to all the questions. So I think, yeah, I think that is it. So let's go back to this. Cool. Cool. So just for fun, I'm just going to end the poll. It seems that the, oops, where'd it go? Oh no, I just ended the poll to hope, I was hoping that the results would show to everybody to see which lesson was the favorite, but, oh, there it is. It just got posted. So it looks like most people liked lesson 5 and lesson 2. Awesome. Okay. Well, that's really all I had for you. I'll hang out and answer questions in the chat. Also, you can see the link to my Discord server, which is to my, am I pointing the right direction? I don't know if I'm pointing the right direction. Nope, this direction. You can get to my Discord server. I'll be in the Discord server answering questions or, hanging out if you guys have questions. Whatever. If you guys have questions or want to talk about anything else. But insofar as the live stream, thank you so much for joining. The last few questions, how old was I? I started my networking journey. I started with computers when I was, say, 18 or 19 with the U.S. military. I was in the Air Force. And then my networking journey, I started probably 2022, about 4 years later, is my first networking-based role. Oh, man, this kind of dates me, but I guess that was 15 years ago. Yikes. Yeah, good stuff. So Kranti asked, the full course probably will. Module 1 probably won't, Kranti, about those devices. But remember, a lot of those devices just do routing and switching, just the way that we've explained routing and switching to work. So definitely check out Module 1 to really understand how those are processing the data. Frank, I do actually have a series of packet tracer videos. You can find them on my blog. practicalnetworking.net. I believe it's one of the last few things that I posted. So I think I've done 4 packet tracers where I walk through the lab myself, and then I actually have a packet tracer challenge lab where I give you a lab to see how you do as a challenge. Cool. Yes, Ramiro, this will definitely help you with your Network Plus. It's very squarely straight in the content that you need for Network Plus. Vinay, yes, it's an option. I could fire up GNS3 and do some labs there as well. Awesome. I don't currently have CCNP, Encore, or NRC videos. Some of the content that I have put together already does touch that stuff. So again, I would take a look at my blog, pracnet.net/ccna. You can see all my my Cisco related stuff there. Cool. In any case, that's all I have for you guys today. Thank you so much for joining. I'm going to jump in my Discord. If you guys have any questions, feel free to take a look there. Once again, the link is going to be right here. You should see it on the stream. You can access it at pracnet.net/Discord. Otherwise, thank you so much for joining. Appreciate all your times. Thank you for all the support. Most, I imagine, or I guess I should go through hopefully you guys have subscribed. Please do if you haven't. And again, the best way to thank me is to spread the word about this content. So tell your friends, tell your coworkers, tell your classmates, post it on different forums, post it on different places where people want to learn how networking works. Again, the short link to that is pracnet.net/NF for networking fundamentals. Thank you so much for joining me. If you guys have anything more, please hit me up on Discord. Otherwise, have a wonderful rest of the day, and I'll see you guys in the next stream. Thanks, guys.